So the mean distance of the electron from the nucleus is not the only effect, the only thing that is going to affect the relative energies between the 1s and the 2s orbital. Okay, we also have to consider a phenomenon called shielding. Okay, and so what shielding is when we're thinking about more than one electron within an atom. Okay, so let's say we have an electron configuration where we have the 1s orbital filled, and then we have an electron in the 2s orbital. Okay, so in other words, right, how we think about how the electron interacts with the nucleus we have to modify this because it's no longer the interaction between one nucleus and electron. It's now the interaction between a nucleus and electron, and then a second electron with a negative charge, right, which we'll call Q3, okay? But then you have the interaction between the two electrons, right? And so we have R between Q1 and Q2, right? Or the radius between Q1 and Q2 to think about. We have the radius, well, let's annotate that, or let's shrink that down to just R12, right? We also have the radius between the nucleus and the second electron, and then we have the radius between the two electrons, okay? And so briefly, right, what that means is our force, right, attractive force, is going to be a sum of three terms. So it's going to be the sum, so between 1 and 2, right, so the nucleus and electron, okay, 1 and 2, plus the force component of 1 and 3, plus the force component of the two electrons, 2 and 3, all right? Now, much like when we talked about just the interaction between Q1 and Q2, right, because this is between a positively charged nucleus and a negatively charged electron, that's going to be attractive, right? So this is going to be attractive. Similarly, the interaction between the nucleus and charge 3, or the second electron, is also going to be, attractive. This will also be attractive, right, between the nucleus and electron 3. However, right, because the two electrons are also interacting, right, that's going to be a repulsive force because they're two negatively charged species. Okay? So the overall interaction between the nucleus and any given electron is going to be less than it would be in isolation if that electron, in other words, if that electron was the only thing that was within the atom, okay? Because now this electron, right, the second electron is repelling the first electron, and therefore it's doing what we call shielding, okay? So second electron is shielding the first electron. All right, and of course, as we get to have more and more electrons within an atom, right, there's going to be a lot more of this interaction between other electrons, between other electrons. So, for instance, we would have in this scenario where we have an electron in the 2s shell, 2s orbital, and the 2 electrons in the 1s electron, the 2s electron would feel shielding from the electron, both the lower energy electrons in the 1s shell, okay? And so the sum effect of this is that we can think of any given electron, right, as having, still feeling an attractive force to the nucleus, but it's much less than what it would feel, again, if it was the only electron in the atom. And so we call this lower, we can refer to the effect of this lower attractive force as having a change, an effective change on the nuclear charge, and so we call this term the Z effective, okay? And so Z effective will be less than the actual nuclear charge for the nucleus, okay? And that's going to depend on the electron configuration of the atom, right? And so this occurs, and so the way to think about it in this case, right, is if we look at the electron density, right, in addition, right, to the effects we discussed before, there's an additional alteration in the relative energy orbitals, energies of the two orbitals, because the electrons that are in the 1s orbital, and therefore are typically closer to the nucleus, right, on average are closer to the nucleus than the electron in the 2s orbital, right, is going to shield, right, so these two electrons are going to shield the second electron, and so therefore this electron in the 2s orbital, and therefore the energy of the orbital, I should say, is going to be higher in energy because of that, because it doesn't feel the entire charge of the nucleus because of the repulsion between the electrons within the system.